Today I'm going to be looking at graphing in slope-intercept form. So slope-intercept form is the form of y equals mx plus b. So in this video we're going to take a couple looks at a couple different examples of what we would do in different scenarios that could pop up when we are graphing in the form of y equals mx plus b. So let's first talk about that form of y equals mx plus b. So the form slope-intercept y equals mx plus b. M represents our slope when we go to graph our line, and then the b represents the y-intercept. Some people like to think of the m as move, and then the b as the begin point. So b tells us our y-intercept, so where we cross the y-axis. And then the slope tells us which direction to head from that y-intercept and what the line will essentially end up looking like. If it's positive, it's going to be sloping one way. If it's negative, it's going to be sloping the other way, and so on. So let's talk about slope a little bit more than just it's being defined as m. So slope is defined as rise over the run. So rise meaning how many units we're going to go up or down, and then the run, how many units we move left to right. So that means on our slope, if our top number, so I'm going to say the rise is our up and down movement, and then the run is our right to left movement. So I always like to think of this as if the top number is positive, that means from our y-intercept we're going to go up. If our top number is negative, that means we're going to go down. And I know we could put the negative with the top or the bottom or off to in the front, and then we just have to decide for ourselves where we put in that negative with the top or bottom. So if the bottom is then positive, that means we're going to go to the right. If we put the negative with the bottom, that means we're going to go left. So top being positive, we go up. Top being negative, we go down from that y-intercept, that begin point. Bottom number being positive, we go to the right. Bottom number being negative, we go to the left. So the slope is our rise over run, our up and down over our right to left movement. And we do have a formula for slope where you would have y2 minus y1 over x2 minus x1. And you could piece that together from the fact that rise over run. Well, y2 minus y1 tells us our distance in vertical change. And then our run is the distance in horizontal change. So let's just say I had like 2 points like here and here, and I had this line. The run would be, or I'm sorry, the rise would be how many units? 1, 2, 3 over 1, 2. So our rise is 3 over 2, a positive 3 over 2, our rise over our run. So we went up 3 vertical units, and then we went over 2 horizontal units. So our slope in this line that I just created would be 3 over 2. And in this video, we're just going to look at just the equations in the form of y equals mx plus b. Not going to look at any sort of, here's 2 points, we have to come up with the equation, then graph. Like, we're not going to look at any of that sort of stuff. Just going to be all the different forms that could happen when we are graphing in the form of y equals mx plus b. Let's take a look at the first one. It says y equals 2x plus 1. So first, you always want to identify your slope and your y-intercept. So the slope is that term in front of the x, that m term is right here. So our slope is 2. What does it mean when it's just 2? Well, the top number is 2, so that's our rise. What is the bottom number? If I don't have any number, that's just over 1. So that means our slope, positive 2 over a positive 1. If the top number is positive, I'm going to go up 2. Bottom number is positive, that means I'm going to go right 1. So from my y-intercept, my begin point, I'm going to go up 2 to the right 1. What is our begin point? What is our y-intercept? This positive 1 is our y-intercept. So we go to our graph. We find the y-intercept of positive 1, which is right here. And then our slope is up 2 to the right 1. So from this y-intercept, I'm going to go up 2, 1, 2 to the right 1. 1, 2 to the right 1, right here. I do not put it, this is a very common mistake I see, up 2, and then I see people like put a point right here indicating, oh, I went up 2 points, and then I'm going to go over 1. That is not a point. The slope just tells us how we get to create that line. What do we have to do to create this line with that given slope of 2 over 1? So I have to go up 2 units over 1. And then I typically like to get a couple points, like maybe 3 or 4 if possible. 1, 2 over 1. Up to 1, 2 over 1. And we can connect this, but I want to talk about doing the opposites, just in case we're in a scenario where we started here and we're out of room. If we can't go up 2 over 1 and we're completely out of space, how do we combat that? How do we still graph this while staying with that same slope? Well, what's the opposite of going up and to the right? You want the complete opposite. So the complete opposites would be going down. Opposite of up is down. And then what's the opposite of right? Left. So we go down into the left. So I'm going to go down 2 units, 1, 2, to the left 1 unit. Down 2, 1, 2, to the left 1 unit. So then there would be our line, which I will make my best effort here to create a line here. There we go. Not bad. So then that would be our line, and obviously we'd want this to be a little bit better. There it is. Cool. Perfect. So there would be our line for y equals 2x plus 1. And I'm showing you these different strategies of like up and to the right and down to the left, just because it's useful. It's good to know how to do one direction and then being able to take that and do the opposite. Because some scenarios we might be in a situation where we need to know how to go both directions with that. All right, let's take a look at the next one. Y equals negative 3x minus 2. So in this one, our slope is negative 3. Same discussion as we just had with the sloping just a coefficient of just a number, not a fraction. This is going to be over 1. Our top number is negative, so that means we're going to go down 3 units. And then the bottom number is positive, so that means we want to go right 1 unit. Don't let the negative throw you off thinking like, oh, it's negative, so I'm going to go down and left. I'm going to make both of them negative. No, the negative could only be on top or it could be on bottom. If you wrote it like this, negative 3 over 1, where it's the negative out in front like that, then in that scenario, you want to designate the negative being either on top or bottom. So either rewrite it like this, or rewrite it like this. Either way, you're going to get the exact same line, but you do not want to think of this negative 3 over 1 as negative 3 over negative 1. It's one or the other. So now we have to identify our y-intercept. Y-intercept in this case is going to be negative 2. So we start at negative 2. So y-intercept of negative 2. Then I want to go down 3 to the right 1. So 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. What's the opposite of going down and to the right? Up and to the left. So I'm going to go up 3, 1, 2, 3 to the left 1. Up 3, 1, 2, 3 to the left 1. And then I'm going to make a perfect line again, just like how I did last time with no assistance, completely freehand. There it is. Freehand, no assistance whatsoever. And there's our line. So in these last two examples, we just looked at values of just a number over 1. So something over 1. Let's look at a scenario where it's not just over 1, where it's an actual fraction. So in this one, we have y equals 2/3 x minus 3. So my slope is 2/3, positive and positive. So that means I'm going to go up 2 to the right 3. My y-intercept is negative 3. So I'm going to start at negative 3, right here. My slope is 2 over 3, so I'm going to go up 2, 1, 2, to the right 3, 1, 2, 3. Up 2, 1, 2, to the right 3, 1, 2, 3. What's the opposite of going up and right? That is down and left. I'm just going to rewrite that in a different color. Down and left. So this is our starting points. So we're going to go down 2, 1, 2, to the left 3, 1, 2, 3. down 2, 1, 2, to the left 3. I just lost it. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. All the grids start to just blend together after a point. So connect it, making a perfectly straight line, no assistance. Got it. And there's our line for y equals 2/3 x minus 3. Last scenario I have is negative 1/2 x plus 1. So negative 1/2 x. First of all, we have a fraction. And then second of all, we have this negative. So I was already kind of talking about this. This is going to be our slope. This can either be negative 1 over 2 or 1 over negative 2. Either or, but one or the other. It can't be negative 1 over negative 2. So let's say I'm going to go with the negative 1 over 2 because I think that's a little bit more natural. I think more people would probably just go with that route. We're putting negative with that value. So that means I'm going to go down and to the right. So what's my y-intercept though? My y-intercept is positive 1. So positive 1 is here. I'm going to go down and to the right. So down 1 to the right 2. Down 1 to the right 2. Opposite. Up and to the left. Up 1 to the left 2. Up 1 to the left 2. And here's our line. So this scenario, probably one of the most difficult scenarios of these four that we've looked at here, just because of that negative and the fraction. You just have to make sure you're putting that negative with either the top or bottom. I can't emphasize this enough how many times I've seen people just put the negative with both. Or another common error is not being able to do this opposite. And it's not like we need to know the opposite. Like I would have been fine just creating 3 points. I could even gone like maybe 4 or 5 and just been perfectly fine on the graph. But it wouldn't hurt to just get used to that rhythm of going both directions, of down and right, up and left, and all the other examples that we looked at. Just gets you better at graphing in slope-intercept form and gives you a better understanding of slope and what that does to the line. And we could see in this example, this negative 1/2, what does the line look like? It has a negative slope. In the example here, positive 2/3, what is that line? That is a positive slope. So the sign of the slope is indicating what this line ends up looking like. Negative slope, negative line. And then here, positive 2, positive slope. So there is a correlation there between the slope and the way the line actually looks. I'll leave it at this last one. So I hope this helps with graphing in slope-intercept form.